Hi, in this video, I will be showing you problem number 13 of chapter 7, section 8. Determine whether the integral is convergent or divergent. Integral negative infinity to positive infinity, 9x e to the negative x squared dx. So this is also an improper integral of type 1 because the interval over which the integrand is defined is an infinite interval. So it is improper integral of type 1. Now we can split the integral into two parts. One is negative infinity to 0, 9x e to the negative x squared dx, then plus 0 through infinity, 9x e to the negative x squared dx. We'll call integral I as I sub 1 plus I sub 2. Then we will evaluate I1 and I2 and plug it back in here in this step 1. So let's work on I1 first, which is negative infinity through 0, 9x e to the negative x square dx. Note that this is also an infinite integral. So you have to write this as limit as t approaching negative infinity, integral t through 0, 9x e to the negative x square dx. I will substitute, we'll use substitution technique here. So let's assume u equal to x square. So du will be 2x dx. So if you just look at the integral, 9x e to the negative x square dx, to be 9 outside, integral e to the negative u, then we have x dx, that will be du over 2. So it is 9 halves negative e to the negative u, or negative 9 halves e to the negative u equal to x square. So in I1, we can write it is negative 9 halves. Of course, we have to remember to put the limit t approaching negative infinity of this integral, which we evaluated negative 9 halves e to the negative x square between the limits t and 0. So if you plug in the upper limit for x, it will become e to the 0, which is equal to 1. So that will be negative 9 halves. Then if you plug in the lower limit, you will have e to the negative t, but t approaches negative infinity. That will be 0. So I1 is just simply negative 9 halves. Then we will do I2. I2 is integral 0 through infinity, 9x e to the negative x squared dx. Can apply the same technique except that we have to allow t to approach infinity. Then evaluate that as integral 0 to 2, 9x e to the negative x squared dx. We will have the similar computation here. So it will become negative 9 halves e to the negative x square, but the limits are from 0 through t, then t approaches infinity. So at the upper limit, the spot would be e to the negative t approaches infinity, that will be a 0. Then at the lower limit, it will become e to the 0, which is equal to 1. But at the being lower limit, you will have a negative appearing here. So it will be plus 9 halves. So I2 is positive 9 halves. So I in step 1 in the step, which is I1 plus I2. I1 is negative 9 halves. I2 is positive 9 halves. So the value of the integral is 0. But the question is whether the integral is convergent or divergent. If the value of the integral is a finite value, then integral I is said to be convergent. I is convergent. Hope this video helps.